Hi everyone, good morning. Let's just wait for 1, 2 more minutes. For all of you able to try that particular problem yesterday so that we can discuss your approach today. Were you guys able to do some practice yesterday? So today, what I thought is we will discuss your approach, okay? And we'll cover the points that I told you to find in the data yesterday. So who would like to go first? Am I audible to everyone? Yes, no. Okay. Were you able to work on the problem or not? Whatever steps I told you yesterday. I gave some steps, right? Which I asked you guys to perform so that you can do EDA, right? And then today we had to discuss those. In case you haven't done, okay, let's do it now. Okay. The first thing that I want you to do is just do a univariate analysis, right? Just show you. Start with some univariate analysis, okay, of each of the categorical variable, then each of the numerical variable. See the distribution of purchase, right? And then tell me the insights about it. Then I'll show you how I have done. Can you all do that? I'm listing the steps again, okay? You have to perform the EDA. You have to do univariate analysis. Then we have to do bivariate analysis. Have you guys done this or not? If you haven't done it, okay, we can do it now. Just writing the steps which I wrote yesterday. Yes, these. Please start with this right away. Okay. And then once you are done with univariate analysis, let me know. Yesterday, one of you were asking about the credit card problem. So I asked you to draft an approach. Latanya, I think you were. So have the approach, we can discuss it now. For all others who have just joined, I'm expecting these univariate analysis and bivariate analysis from you. Okay. It's very simple. Okay. All you needed to do was just plot it out and write your insights. Okay. So for example, here I can tell, okay, male data is more than female. Univariate is very easy. Similarly, age distribution, you can see that most of the people are from 26 to 35, right? So please complete this so that we can discuss what are the insights from the data. Okay. So yesterday we looked at more of a Python basics, right? We explored the data, we merged the data a bit, right? We tried to understand some of the points, but today we'll do the EDA. Okay. Once we do the EDA, we will go with the baseline approach. Then we'll do some data pre-processing, and finally we'll build our models. Okay. So once you are done with univariate, tell me the insights. Okay. Like these are the four insights that you can see in the data. Then when you do bivariate analysis, okay, so this is the five insights that you can see in the data. Okay. And I want it from everyone. And please, this is something you should have tried at home. Okay. See, insights matter. Like insights के बिना कुछ फायदा नहीं है. If I'm running the code, that's not making, that won't help, right? जब तुम interviews भी देने जाओगे, ठीक है, and when I also take interviews, I look for this, right? Yeah. What is skewed? What is not skewed? Right? What impact does it has? Right? So for example, if purchase, yes, the purchase is not so skewed, but थोड़ा बहुत जो भी है, right? Maybe what you see is that what could be the reason. So so a lot of people don't purchase much, right? Could be one reason. So kindly do this and tell me the five insights using your univariate, bivariate analysis. So five pointer which helps me understand the data. Ask the questions from the data, right, and get me the answers. Okay, so basic approach data analysis. Okay, the first part is defining your problem statement, right? Okay, understanding the data that this data might be unbalanced, right? Data analysis हो गया, basic stats inference हो गया, right? Missing value imputation and all that is fine. There should be a baseline model which will come even uh, at the second step. Okay. So baseline model could be as simple as you assigning everything randomly. Okay. So random से कितना अच्छा तुम्हारे models ने किया, this you will get to know once you create a baseline model which is before all this random forest decision tree and all those. Okay. For example, you randomly assign who is going to fraud or not. ठीक है, रैंडमली तुमने डिसाइड कर दिया, सबने तुमने डिसाइड कर दिया नॉन फ्रॉड, तो क्या तुम्हारा वो आ रहा है, प्रिसीजन रिकॉल, राइट? एंड डिफाइन योर इवैल्यूएशन मेट्रिक्स. So the first step will be problem statement, second is your evaluation metrics, okay, third is you load the data, right, and fourth is you create your baseline. Okay, from there you start then with your data analysis, ed and everything. Then you come to machine learning model, then you looked at correlation metrics and heat map and find feature importance. ठीक है, फीचर इंपॉर्टेंस कैसे निकलेगा, रैंडम फॉरेस्ट का डॉट फीचर इंपॉर्टेंस यूज कर लो, डिसीजन ट्री का यूज कर लो. ठीक है, एंड देन ऑल्सो ट्राई मिक्स ऑफ बोथ मॉडल्स. सो दोनों के आउटपुट से, लाइक लेट्स से रैंडम फॉरेस्ट हमें बोल रहा है कि ये फ्रॉड होगा, और लेट्स से कोई और लेट्स से एक्सजी बूस्टर वो बोल रहा है फ्रॉड नहीं होगा, तो तुम दोनों के कॉम्बिनेशन को भी यूज कर सकते हो. ठीक है, एट टाइम्स. और आउटलायर डिटेक्शन, ओके, कोरिलेशन देखा, आउटलायर देखा, स्टैंडर्डाइजेशन देखा, उसके बाद तुमने दोबारा से मॉडल बनाया, तो ये वाले मॉडल्स को दोबारा ट्राई किया. ठीक है, एंड देन सी कि तुम्हें कुछ इंप्रूवमेंट मिल रहा है या नहीं मिल रहा है. ठीक है, और इसमें सिंस इट्स अ अनबैलेंस्ड प्रॉब्लम, ट्राई टू यूज स्मॉट. ओके, तो याद है हमने एक एग्जांपल एक प्रोजेक्ट में स्मॉट यूज किया था, वेयर वी imputed the data, right, where we added more variables, so you have to do that. Okay, is it clear ना, क्या स्टेप्स फॉलो करने हैं? तो लिख लो steps so that you know what all steps you need to do, and then you can spend time on it and do each and every step. Okay. So what we can see here is in the univariate analysis, male are more, and then probably whosoever is buying, if you see 26 to 35, this is the age people are buying a lot, right? Neither teenage people are buying much, neither old age people are buying much. Okay, main is this age, which is mostly working class. I mean, people who are working from quite some time, right? Even 18 to 25 is less because they prefer to go out and buy, right? So, online sales, mostly this age bracket is the person who are driving this particular thing, right? Marital status, okay. Unmarried people are buying more than married people. Occupation, we cannot know much, but there are few occupation who buy a lot as compared to rest of the others. Similarly, in product categories, we can see these three categories: 1, 5, and 8. These three categories are the most. Similarly, in product category 2, 3, right? In city, I mean, B is buying more than A and C. So again, you know something out here. The occupation. Next, what I've done is I've created a pivot table. Okay. And inside this pivot table, do you all know how to create pivot tables in Excel or in Python? I mean, you should know in Excel, then only you can build into Python. Yes, no. Do you guys know yes or no? Okay. So pivot tables आसान है, ठीक है? What you need to do is, let me just quickly tell you. तो देखो इसमें the important things to note is, and let me just show you this. कि क्या rows आएंगी, क्या columns आएंगी, that's it. So here what we have done is we wanted index. So basically this is similar to group by. So I want a group by occupation. Okay. And I want group by on purchase value and I want to look at mean. So basically what it is showing is the mean purchase amount for each of these occupation. Similarly, if I would have done it on gender, this is mean purchase value by gender. Now I can do mean, I can do max, I can do min, and see different things in the data. So this is a much more generic function that you can actually use. Okay. So let's try to use this. I mean, this, it is already there, but we have done with age and purchase. So you can see there's no much pattern. So if you see average sales, I mean, you are not finding any pattern with occupation, neither with the gender, neither with the age, neither with the gender. So these are the three bivariate analysis that we saw, which we didn't find much, right? The next thing that we could still look at is, let's try to look at, so we looked at gender, age, occupation, nothing, right? Maybe city we can see. Is there any variation with respect to city in terms of purchase? So as you can see, 8911, 9197. So bit of a difference, but not too much. But 0 and 2 are very different. So 2 is much more than 1, right? That we can see. Okay. Now, if you want to group with more, so let's say you want to group at city as well as gender. You can create this multi-level index also. Okay. Similarly, on values also you can do that multiple aggregation. Okay. Let's look at product categories also. Product category wise, this is something interesting where you can actually see a lot of difference. So let me just plot it out. I'll just name it as product plot. Here you can see some difference. So probably product category has, I mean, different mean values for different products. This is something we were expecting also, right? Because every product category will be different. Okay, let's look at product category 2. Not much of a difference as compared to product category 1. And obviously we can see there are blank values also. So that is always there. Let's look at product category 3. So with bivariate analysis, one thing that you can conclude is product category 1 and purchase has some amount of correlation. When I say correlation, what I mean is that there are, for different products there are different purchase, but across gender, across age, across occupation, there is not much of a average spend behavior. I mean, average spend behavior is same across different occupations or age or gender, right? Fine. Now, instead of mean, you could also look at median to be very sure about it. Okay, so let me just keep this and let me do median out here. In fact, median is even straightforward, so nothing much out here, but I'll still check median for all because mean can be skewed, but if you see median though is almost same for everything. There is nothing much you can actually uh, do with bivariate analysis in this case because only product category 1 is where you can see some variation, right? And in others you cannot. Are you guys having the same insight as what I got? Yes, no. Okay. So next we come up with our baseline model. Okay. So this is a regression problem. So my baseline could be as simple as just giving an average. Okay. So what I'll do is before I pre-process the data, okay, I'll create my baseline model out here. Baseline model could be very, I mean, it could be very simple, stupid, or whatever you can say. Okay. So in my case, what I'm doing is this is the purchase, right? This is my value, mean value. So what I'm doing is I'll create a prediction column and I'll say जितना एवरेज है पूरा कंट्री का या पूरे डेटा का उतना ही लोग परचेज करेंगे. So that's my prediction. So I did this. Okay. Now I have to obviously check how good or bad I am doing, right? So what I'll do is, since we had to use the metrics to identify how good or bad we are doing, so let me check. So this is my predictions. This is the actual value, right? How do you get RMSA in Python? Since that was the criteria we have to see. How can we get RMS in Python? So in the same function, if you do small change, you can do that way also, but there's a very simple way also. Uh, so in this, there is this squared is equal to true. Just change this squared is equal to false, and this is nothing but your RMS. You can see 5023, and this is 25. Okay, so this is our baseline model. We got an RMSE of this. Fine. Now I'll just move few steps ahead. Okay, let me just drop this column. Since I don't want to disturb this, let me just do whatever I have done. I'll walk through this later, what I have done. Random forest, CNT regressor. Let's quickly look at it. So if you see, I'll just rename this thing. Here, what we'll do is instead of this, I'll just change it. Okay. So just to have a consistent values, which model is getting trained. Let me just stop it. Since it's a huge data, so just keep in mind that training will consume some time. So whatever you try it out, just make sure that you know you try it out in a better way. So my RMSE with a linear regression is coming out to be 4617, and my RMSE without any model was coming as 5023. So now you know that how good or bad you are doing, and that's the importance of your baseline model. Baseline model, did you need to learn machine learning? No, right? You just need common sense, right? Yes or no? Now this baseline model you can create with different things. You can use median, or you can say, acha, with gender I'll be specific. Okay. So now like you can try to create your baseline model maybe which is gender specific. So like अगर male gender है तो यार वो 5,000 रुपए खर्च करेगी, something like that. So if I'm, let's say, female or a male, right? I can say in with my baseline model, it's highly gender based. Uh, if a female is spending, she will spend around 4,000. If a male is spending, he's going to spend around 5,000. So you can create your baseline model like that also. Okay. So can you try creating your baseline model like that and give me the uh, baseline number with it. So all you need to do is, instead of just mean, male ka alag mean karna, females ka alag, right? And then give me these three values. Till now we are not doing any pre-processing anything. Okay. I was just wanted to show you what could be done. Okay. That's why I just went bit few steps ahead to see. Guys, the task is very simple. All you need to do is, like the baseline model I have created is just a mean. What you need to do is, for female and male, you have to use different means. Okay. So what is the RMSC? Okay. So it reduced slightly, I think, right? 5013 and we had 5023, but not major difference. But yeah, that's fine. That's fine with our baseline model. Okay. And you can try, I mean, gender is one. You could have tried with product category. You could have tried with uh, maybe occupation, right? Or a mix of both, right? So basically, you can add and try a lot of things in your baseline model, right? Or median, exactly. But the essence is that you should not do worse than this. Okay. So when you go for interviews, I mean, many people miss this approach. They will say, okay, I applied decision tree. अरे यार decision tree तो कोई भी apply कर सकता है. How well you understood your data? If I would not have used machine learning at all, what was my score? Right? How good or bad would I done? Right? So that's one thing that needs to be there. Okay. So next, what I have done is I fill in the NA values, right? I just created a new category and filled it. Okay. Yesterday we tried with B fill and F fill. You can actually use any of those approach. Yep. This is something which is not required. Okay. So I've taken just one, two, three columns, right? I'm just doing label encoding for these, right? Just to have consistent values. But since this is already in uh, numbers, you can actually skip that also. I mean, for gender, you might have to do, but for others, you can actually skip. Let me just reset it. So let's prepare the data for training. Okay. If everyone has completed their baseline approach. Uh, but it's a categorical data, so you have to think a bit more about it. Yathan. I mean, you can do it with zero, but there is if there is already a category zero, then it might not make sense, right? Okay, cool then. So age, city, category, I'll just apply label encoder on it. Okay, so just quickly do this. Okay, all you need to do is initialize the label encoder, apply it, right? And mostly now you should have the data. Okay, let's also check the correlation metrics to see if we have some correlated variables that we should drop. So not much of a correlation that I can see. Typically around zero point 0.3 or something, right? Let's drop the columns which are non-relevant. So user ID, product ID, and purchase is my target. So adding that to the target variable, and X will be my predictors. Let's do a one thing which we haven't done is splitting the data and then actually checking our train and test model rather than just putting everything out there. So all this, so most of the time you can see examples here also. So I generally do this. I copy this from here, from their documentation only. I've already done it here, so I don't need to do it. I've done it inside this. I created a train function. Okay. And inside this, I've already done this train test split. I'm fitting it on train, predicting it on test, checking my cross validation score, right? Then just print out the results. So first thing we do it with linear regression. Says around 4617, which is decent, right? As compared to whatever we got earlier. And if we plot model questions, then we can see that occupation, stay in current city and product category 2 are not adding much. So I can actually create another model out here by removing these. Okay, so let me just do that. I'll do is I'll again call this and instead of this, okay, so instead of this, I will drop columns is equal to one is occupation, another is stay in current city. And then product category 2. Dropping this didn't have much impact. So maybe the coefficients are small, but they are still relevant. This, so that means we cannot just drop it like this. These are small, but they are still impactful. Okay. Now, the next thing that we do is, and as of now, we haven't created any features. We are just using as is. One feature that we can try is combining these product categories into one. Then I call my decision tree. These two models will take some time. From this feature importance graph, we will actually see which features. Yeah, now you can see product category 1 is playing the most important role, and my RMSE has dropped further using a decision tree regressor to 3366. So you can see the improvement we have made from our baseline to a linear regression to a linear regression by removing some variables. Then decision tree regressor. Okay. Let's see with what happens with our random forest and extra tree replacer. Any questions here? Now, when you are explaining it to interviewer and when you're explaining it to the people, you have to tell them that you build a linear regression model firstly. Okay. I mean, after your baseline, then what you could see in your linear regression model is that there is definitely some non-linearity in the data. That's why it was not getting captured properly, because you could see it in age. I mean, few variables you can see, but all of these values were dampened out when you looked at model coefficients. So that's why you tried with some nonlinear approach, which is nothing but a decision tree to start with. And once you started with decision tree, you can see actually product category one not having too much importance here. I mean, gender was more than this. But as you moved here, this was one single category that had the highest importance, and gender was the one category which had the least importance. So that proves, and even the RMSE value proves, that there was something really wrong with the approach of us using gender as the gender as one of the key values, right? And why the CV score is important is because you test with different test data to be very sure. So make sure you are using this cross validation score. Okay. So cross validation में क्या होता है? You divide your data in 10 parts, let's say, and let me show it. So let's say there are two, three, four. Let's say you divided the data in your 5 parts. Okay. So अभी तुमने क्या कि एक पार्ट टेस्ट के लिए रख लिया. The rest of the parts you used for train. Okay. As of now, तो we create this particular model. Just this yellow and maybe this as green. Okay. Now what we do is we can actually shuffle this. अब मैं नेक्स्ट आइटरेशन में इन सबको ट्रेन बना दूंगा और इसको टेस्ट. उससे नेक्स्ट में इन सबको ट्रेन बना दूंगा so that we actually checking all the iterations of the data. Similarly, I can repeat it 5 times, right? So this is nothing but cross validation. So you provide your model, okay, and provide the whole data. What it will do is it will keep this test other as train, then it will keep this as test other as train, and keep on repeating this. Okay, so let's quickly see if this model has completed. So with decision tree, random forest will take some time. I mean, this is a big system. So if you see, our almost full CPU is also occupied. I mean, a lot, 399% it is showing. As of now, we are not using any server, but this will take some time to run because it's a huge data. So you have to be patient enough. Any doubts? Yes, no. It's finally completed. So see the RMSE has 3063. So we are doing even better than our random forest. Let's do this. Let's make some prediction. Let's go this data. And let's apply all the transformations we applied on our train data. Just this. So one is we have to change this, and then there is we have to do this. Thirdly, we have to do this. These are the three transformations that we applied. So we apply it on the test data set also. Let's quickly copy it here. So this will be our test. Whatever transformations that we did out here, we have to do the same, just to make the data same. And now we can actually do the predictions, and then we will submit these predictions on the analytics with there. So model.predict, and inside this test, all we had to do was whatever we passed as X. Okay, so जैसे हमने ट्रेन में किया था वैसे ही हम इसमें करेंगे. Which is not found in access. Yeah, obviously it won't have. Should create one variable which is nothing but, so my sample predictions कैसे थे, sample submissions where we had this particular value. Which has purchase, user ID, and product ID. So purchase is the column which we need. So I'll just write that. Then we can just create one more data frame which has purchased, which has user ID, which has product ID, and dump it to a CSV. Submission dot CSV, and index is false. I have it here. So I'll just quickly download it. Let's head back to Black Friday problem. Let's just do a submission. This is a submission file. They want always look for some code, so I'll just upload any code. Let's see where we stand with our analysis. So the score is almost 3058. So if you see, this score almost matches with what we got with our train test bed. So that means, I mean, we are good enough. Okay. Let me check the leaderboard. So you're not too bad. I mean, you can see we are at 1900. I mean, I think 1900. Yeah. Obviously, people have better models, right? So we have to try it more and get to those scores, right? Just checking the worst values. People have like 10,000 as their RMSE. So as compared, we are good with our simple model also, right? Now we can obviously work on improving this approach. I mean, one of the next approach that I could see is uh, we dropping these variables which are not adding much importance, okay, and then retraining it. Also, we can try with another models like extra tree regressor and see where are we working. I'm sharing this code with you. For you guys to try it on and take it to the next piece. Any questions, anyone? See, the more questions you ask, the better I can tell you, right? Okay. So जितना तुम लोग practice करोगे उतना ही पता चलेगा, right? So just try to run this now, okay? Just copy this code in yours and tell me the scores you are getting. The next thing is try to remove some features and then try to add some features, okay? People got best result with an XGB, okay, XG boost, okay. So if you can see 2496 is with XG boost. I was looking at someone's solution. So try with XG boost and you will definitely get better results. Because the rest, most of the things that we have done is fine. I mean, whosoever wants to, I'll just copy this. Also upload my solution out here. You can actually look at this. This is the solution we have already. Please try it out and let me know.